Thank you. Hi everyone, my name is Joran, and well, if you're here, you probably already know what I'm going to talk about. But basically, I'm going to have a look at this new cool language. Well, it's relatively new, I guess, called Cairo, and how easy it is to mess things up, and what kind of bugs you should be looking out for as both a developer or a bounty hunter or a hacker. So first things first, let me do a very, very short introduction of what Cairo is. I assume most of you already know, but it's this quite cool programming language built by the guys over at Starkware, and its goal is to allow for verifiable execution. And what this means is that outside of doing some computations, which regular code does, which Solidity does, or your regular JavaScript and Python, what it will also do is produce a zero-knowledge proof showing that the result that is computed was actually computed using the code. This, in our space, is very, very useful because what we have right now to do this is a very naive method, which is just rerunning the code to see if you get the same result. And in this case, it's easy. You can just check the zero-knowledge proof. And so I want to dispel a myth, and I'm not sure why this is a myth, but a guy was talking to me the other day, and he's like, verifiable execution, doesn't that mean that the code is always verified, so there's never any bugs? This is not the same thing. So verifiable execution is about being able to show that what you did was the code. It says nothing about whether the code was correct. And it's actually not that difficult to mess up and have incorrect code. Yes. So the main thing to note here is that Cairo is still a relatively young language. I'm not sure how many people here remember the Solidity 4.04 days. There were a lot of quirks in Solidity at that point, and we've come a long way. And this very, very same thing is happening in the Cairo ecosystem. A lot of the weak points I'm going to talk about today are super well known, and I know that these people are already working on improving it. So I don't want to by any means say that Cairo is a bad language, but when I first saw it, or my first experience with Cairo was like this. I was kind of scared because I saw foot guns everywhere. It's still relatively low level, and there are some quirky things that make it easy to mess up, very much the same as Solidity, which by now has become super mature, and I'm sure that will happen to Cairo too. But that is kind of like a disclaimer. So, in this talk, I'm going to go through 7 sources of vulnerabilities that you as a developer or a bounty hunter or an auditor should probably keep in mind. And the first group of vulnerabilities or attack factors that I'll talk about are things that arise purely from the language. So Cairo works outside of starknet, has many applications or has many potential applications outside it, and these vulnerabilities affect all of these use cases. And the first is probably the simplest vector that I'm going to talk about, which is arithmetic problems. You're probably familiar already with the overflow that you don't need to worry about anymore since Solidity 8. In Cairo, you kind of still need to worry about it. But what's more is the arithmetic happens in a finite field over modulo sum prime, which is weird. Or, well, it's not, it's actually quite simple once you get the hang of it, but at first it has some really weird behaviors, or seemingly weird behaviors. For example, if you take a number, you multiply it by 2, the end result might not be an even number. It can be an odd number. And this is because a prime is always an odd number, so the result of the modular operation could be an odd number. And actually, it's about half of the numbers in the finite field have this effect where you multiply it by 2, then it overflows, and then you get an odd number. Another thing is division doesn't work the way you would think it to. based on like experience with regular languages. So 7 divided by 3, you would either, or usually you would assume it's like 2, like that 4, or like maybe it rounds up, who knows. In this case, that's not true. You'll always get a whole number, but this whole number will have the property that when you multiply it by 3, modulo the prime, it will give that other number, which is a huge number. So basically, you need to worry about overflows and divisions. And multiplications too, but that's kind of obvious. The way to get around this, is to use one of these UN256 libraries that are out there already. They kind of model the UN256 behavior. They are going to be a little bit less efficient than using pure felts in Cairo, but they will kind of solve this issue for you. Then, this is my favorite attack vector or type of vulnerabilities. It's super unique to Cairo or really like zero knowledge based languages. And it's the result of the fact that Cairo is actually not an imperative language. It looks like it, but it's actually not. What the program, a Cairo program is a series of steps with constraints, things that must be true, and it's up to the prover to figure out a way to make everything fit. So this is very abstract. Here's an example. This is something that you could do imperatively or reason about imperatively. You have a variable, you add 1 to it, you put it in y, and you return a y. What actually happens is that the prover gets this challenge. There is a variable y, and it's equal to x plus 1. Come up with this variable y, which is super easy to do in this case because you just take the variable and add 1. That doesn't always have to be the case. So here's a program where you got to find 2 factors of a larger number, and you can see that I first declare 2 local variables, then say that x, my input value, is equal to p times q, which is like this just looks super weird from an imperative standpoint. And basically what you see here is a function that tells to the prover, you return 2 numbers whose if you multiply them, then that must be my input. And it tells the prover nothing else. And well, you're probably familiar with this problem. It's super hard to solve. And this, basically, if you do this, the prover will usually not be able to come up with the result. But in most cases where you would use this is if you can make the constraint super small by saying like, yeah, I don't have a good example, sorry. But what you can do is write these short Python snippets called hints that give a hint to the compiler on what kind of values it would be able to choose for these unknown P and Q. The problem is the compiler or the prover has the ability to choose whether to use your hint or not. It could use anything else. So if you assume that it will run the hint and then not sufficiently constrain what it's allowed to be, what the output of your hint is allowed to be, then the prover can just do anything they want. So for example, if you have a write to like a storage variable called balances, and you don't tell the prover like it needs to be computed correctly, then they might just update their balance to something that they would prefer to have themselves, even though they don't have the tokens. An example of this is dict accesses, where this could happen. The way that a dictionary works in Cairo is that you basically have a list of updates instead of an actual dictionary in memory. And this list of updates is basically a bunch of 3 tuples. I write to this value, it was this value, and now it's the other value. If you accidentally add an unconstrained update into your dict access array and assume that it is not unconstrained, then you basically give an arbitrary write to the prover. And so this is kind of the balances example where the prover would be able to write any value into their balances and basically become rich. Cool. Number 3. this is probably one of the most scary ones. It's the fact that it might be unclear what these built-ins or syscalls are doing. And this is kind of a vague statement, so I'm just going to give an example. This is me writing a function that wraps the verify ECDSA signature, and it adds two asserts that are super weird. You wouldn't write this, but does anybody think that this could ever execute successfully? Like, show of hands. The Starknet guy over there is like, yes. Okay, so what happens is the built-in guarantees one thing, that there is a message there, and that it knows a signature by the key that's provided that matches that message. It doesn't guarantee that these RNS values match up with the signature it knows. Well, this one is pretty hard to actually have a vulnerability around, but it does illustrate the fact that there's unexpected or undocumented behaviors that you should become aware of so that you don't mess up in your own code. Or that you should be aware of so that you can find bugs in other people's code, and then, yeah. Cool, so this is kind of a limitation of knowledge problem as well, like you don't know what you don't know. So read documentation, read the code, that's really the only thing you can do. Finally, in the language class of bugs, there's low-level memory accesses, and this is difficult to exploit generally, but it's super easy to mess up. So in Cairo, you have access to this AP register, and you can write to it, increment it. You can do neat things with it, but it's really easy to mess up, and in general, you should avoid using these low-level things. Same with the dict access. Having an unconstrained element in there, super disastrous, and really the easiest way to avoid it is to just use standard library interfaces to work with the code. Cool. Then in starknet specific vulnerabilities. There's going to be two here, and these are two that are well known, that people have suggested improvements for, that are probably not going to be interesting for long, but at least right now, you should be very much aware of them. So the first one is the way that storage variables work. It's basically the way it works is you have a storage variable, and if it has a particular name, that identifies its location. So if you have two Cairo files in your starknet contract, and they both use a variable with the same name, it will act as if it's the same location. This can be a nice feature, but it's also an easy source of bugs if you don't know it, because like, both of these pieces of code might assume that the other doesn't exist, and updates can be like inconsistent and incoherent. The other thing is accidental imports, and this one is going to be such a nice source of bugs, I think. If you import a file with an external call, or if you import the external call, it automatically gets added to your own smart contract as a callable function. So imagine accidentally importing a change ownership function or an initialize function, even though you don't use any initialization code, and this function overrides the owner variable. This is like an easy way to lose all of your money. So I really like the structure that the OpenZeppelin Cairo contracts have, where the inherited code, or code that you would want to inherit, is separated from the external calls of a particular like archetype. So if you have an ERC20, the external calls are in a separate file from the implementation, at least last I checked. And this provides this nice guarantee that you need to like be very, very intentional if you want to import external calls. Then finally, there is the vulnerabilities that arise from the domain. So, and this is really the easiest slide for me, because I'm just going to say that all the things that are important for Solidity smart contracts are going to be important here too. You'll see your flash loan attacks, market manipulations, reentrancy. So for Cairo contracts as well, it's really important to be aware of all the types of attacks, types of best practices. We have our own, you can check them out there. There's tons of articles on this, but that's gonna be a really, really good source of bugs or something to be aware of. All right. So after this call, a talk, I will post on my Twitter account an ERC20 contract that I wrote when I just started out playing around with Cairo. It has a ton of vulnerabilities in there, so it's good practice for you to see like if you can find any in there. And if you find a bug that I didn't find myself yet, and I hope I know about all of them by now, then I'll probably buy you a beer or something. Cool. So this is kind of the summary of the the 7 vulnerabilities that I think are going to be like a good source of bugs in Cairo contracts. On the language side, arithmetic, it's an old thing, but it's going to stay. Under constraint execution, probably the most interesting thing in this field right now, or at least I think so. Syscalls, undocumented behavior or weird behavior, always a nice source of bugs. And then low-level code, I mean, yeah, people here probably remember C. Then starknet, these 2 things to be aware of are the storage variables and accidental imports. But I think that's going to be a short-term thing where a lot is going to be improved in the language. And finally, of course, always be aware of DeFi hacks or DeFi attack vectors. That's it. Well, good luck if you're a bounty hunter or an auditor finding these bugs. If you're a developer, we at Diligence do Cairo audits now, so if you need one, hit us up, and that's it. So I'll open it up to questions now.
Hi. Are you aware of some shared registry of typical Cairo security issues like SWC for Ethereum, for Solidity, but basically especially for Cairo?
No. Are you aware of any? I mean, they're
yeah, we should probably start a joint effort
yeah.
on that. Thanks.
Another question?
Hey, regarding point number 6, which was about, I think was
yes,
accidental imports. Doesn't using namespaces help with this to reduce? I know I've seen OpenZeppelin use namespace a lot, I think. I'm
not sure to what extent it really fixes it. In any case, you'll have the problem that you can import a function that you didn't intend to. So just having like a list of things that you want and then accidentally having one in there. This happens if like you don't know what you're inheriting. But I'm not sure right now if you import the namespace that doesn't import all the external calls in there.
I might be completely wrong, but what I had in mind is that the issue was that when you call a function, so maybe I'm completely wrong, but what I had in mind is that when you call a function, you call the hash of the function, and that using the namespace, you would actually append, like you would compute the hash of the namespace plus the name of the function, and that would solve the problem, but maybe I'm completely wrong.
So I'm not sure exactly how the function dispatching works at the moment, sorry. But wait, so that wouldn't fix it. So the problem here is that the call is available, not that there is that you don't know how to call it. It's about other actors being able to call initialize even though you didn't want initialize to be there. but good question.
Not a question, more a comment, because I'm the one that makes the PR on OpenZeppelin for adding namespaces. So basically the thing is that we, in OpenZeppelin Cairo contracts, we don't export anything. The namespaces are just for clarity and to make sure that if two ERCs define the same function, there is no clash when you import, basically. But once you import, basically the libraries are just like namespaces with internal stuff. Everything you need to export on your own, which is one of the challenges in Cairo, is that it's very easy to forget to export one of the functions and only notice after the fact.
Great, thanks.
Maybe one last question? No? That's okay? Okay.
Perfect.